Working with big datasets in machine learning can be a challenging task, but it can also be highly rewarding. Here's a general roadmap you might consider when working with big datasets. First, data acquisition. The first step in working with big datasets is to acquire the data. This can be done through a variety of methods, such as web scraping, APIs, or publicly available datasets. It's important to validate the data and make sure that it is accurate, complete, and relevant for your use case. Second, data preprocessing. Once you have the data, the next step is to preprocess it. This includes cleaning and transforming the data to make it usable for your ML model. You may need to drop missing or corrupted data, handle outliers, and extract new features. Third, data visualization. Data visualization is an important step to understand the distribution of your data. You can spot trends and insights that may be useful for your model. You may also be able to identify any data quality issues that need to be addressed. Fourth, data sampling. Big datasets may require a significant amount of computational resources to work with. To reduce the complexity, you might consider sampling a smaller subset of the data to work with. This can help you quickly develop a prototype of your model without having to wait for the full dataset to train. Fifth, feature engineering. Feature engineering is the process of transforming raw data into features that can be used in your ML model. When working with big datasets, it's important to carefully select the features that will be most useful for your model. 6. Data preparation. It's also crucial to prepare your data properly by splitting it into train and test sets, normalizing and scaling it, and so on. 7. Algorithm selection. Once you have pre-processed and prepared your data, the next step is to select the algorithm to use. When working with big datasets, it's important to choose algorithms that are scalable and can handle large amounts of data. Algorithms like random forest, XGBoost, or neural networks are a good starting point. 8. Model training. After the algorithm is selected, you can start training the model using the pre-processed and prepared data. This step can take a while, especially when working with big datasets, so it may be helpful to use distributed computing or cloud resources. 9. Model evaluation. After training the model, it's important to evaluate its performance using metrics such as accuracy, precision, recall, and F1 score. You should also compare the performance of different models and select the best performing one. 10. Deployment. Once you've selected the best performing model, you can deploy it in a production environment and start using it to make predictions on new data. Keep in mind that this is a general roadmap, and that it may vary depending on your specific use case and the complexity of your dataset. It's important to have a good understanding of the fundamental concepts and technologies needed to work with big datasets and ML, such as distributed computing and parallel processing, to ensure that your work is as efficient as possible.